The last part of this section, we're going to deal with two special triangles, okay? When we deal with acute angles, that be, again, angles in the first quadrant, there are a couple of them, a couple angles in particular that are very, very important. The 30-degree angle, the 45-degree angle, and the 60-degree angle. Those three angles are going to help us to identify trig functions in other quadrants, and later, when we get into like chapter 5, we're going to see how those three angles are really going to help us to find other angles, trig functions of other angles, like 15 degrees and 75 degrees and some other ones, okay? So the main thing right now is we're going to focus on three specific angles, 30 degrees, 45, and 60 degrees, and you'll see these show up over and over again throughout this course. So let's start. So the first special triangle that's going to help us out is one called the 45, 45, 90 triangle. It's an isosceles triangle because if two of the angles are the same, that means two of the sides are the same. They're congruent, okay? So let's take a look at an example here. If I were to draw roughly a 45, 45, 90 triangle, and of course it's not perfect, but it's good enough. I'm going to have two 45-degree angles and a 90. Remember, I did say that the two angles that are not the right angle will be complementary, so they have to add up to 90. So 45 and 45 work, 30 and 60 work. So in a 45, 45, 90 triangle, the sides can be anything as long as they follow the Pythagorean theorem. But I do know that the two legs are going to be congruent or equal in length because the opposite angles are congruent, okay? So I can use any numbers I want, again, because we're really going to be focusing in on the trig functions, which are ratios of those sides, okay? So if I use, let's say, side length of 1 on these sides, or side length 2 or side length 3, as long as all three sides follow the Pythagorean theorem, which they should, the ratios of those sides will always reduce to the same thing. So it doesn't matter how big or small the triangle is. So just for ease of arithmetic, I'm going to choose a side length of 1 on these two sides. Okay, so I've got a side length 1 here and a side length 1 here. So we can determine then the third side, which I'm going to call C, based upon the other two sides. Okay, so to do that, I use the Pythagorean theorem. We know that c squared is equal to the sum of the squares of the other two sides. So that'll be 1 squared plus 1 squared. And 1 squared plus 1 squared is 2, right? It's 1 plus 1. So c squared is 1 plus 1, which is 2. And of course, when you utilize the square root property, or taking the square root of both sides, you end up with a square root of 2. We're going to use the positive rather than the negative again because we're dealing with a hypotenuse here, so we don't really need the negative. So we get a square root of 2. And so now I can find all 6 of the trig functions, these 3 and then their reciprocals, utilizing the three sides 1 to 1, and now a square root of 2 on the hypotenuse. Okay? So we'll start off with the sine of 45. Well, and it doesn't matter which 45 degree angle I'm going to work with. I'm going to work with the lower left just because in my mind that's a little bit easier, but it doesn't really matter. So sine of 45 is opposite over hypotenuse, so 1 over root 2. But remember, this is okay except that the bottom is a radical. And I don't want radicals in the bottom, I want to rationalize those. So we're going to multiply top and bottom by the square root of 2. Okay. Again, we've talked about this before, but by doing that I'm multiplying by 1, which doesn't change the value of the fraction, just what it looks like. And so on top, I just have a root of 2, and on the bottom, I have root 2 squared essentially, which is 2. Okay, so root 2 over 2 is the fraction, the simplified or the rationalized form of the sine of 45 degrees. Okay, so this is going to be a very important value to be able to come up with. And again, you can use this 45, 45, 90 triangle if you can't remember these values to be able to come up with them. As a result of that, let me erase a little bit here. We know that the cosecant is the reciprocal of this. Well, if I flip root 2 over 2, I end up with the root on the bottom again. So I'm actually going to go back to the original 1 over root 2, flip that. That moves the root to the top. So what I end up with for the cosecant is simply root 2 over 1. I'm not going to write the over 1 part because that's unnecessary. So the cosecant of 45 degrees is the reciprocal of 1 over root 2, which is just root 2. Okay, so that's the sine. Now we go to the cosine, right? So cosine of 45 degrees, well, cosine 45 is adjacent over hypotenuse. It ends up being the same thing, 1 over root 2. And 1 over root 2, I could go through all this process again. It's going to be root 2 over 2. I'll spare the details. And so then its reciprocal, which is the secant, is going to be the reciprocal, which is just root 2 again. Okay. And then finally the tangent. The tangent is opposite over adjacent, so it's 1 over 1, which of course reduces down to simply 1. Its reciprocal, which is the cotangent, is also 1. The reciprocal of 1 is 1. Okay, so that gives us all 6 trig function values for 45 degree angle.